Hi everyone. So today what I'm going to be doing is this is the most recent Atcoder beginner contest that I haven't done any of the problems from. So I'm just going to virtual participate in it, hopefully solve the problems, and then I'll try to explain them afterwards in more detail. I'll try to explain them in a little bit of detail while I'm doing them. But then I'll dive in a little deeper at the end of the contest. And it looks like we're starting in 4 minutes, just to got a little time for people to join or to get set up, or for me to get set up, though I'm mostly set up already. Hey, um, yeah, so as I'm doing the contest, feel free to chime in with any questions or comments, or yeah, about like what I'm doing or anything else, but just don't give any questions that could be a hint towards the current problem or spoil the current problem or, like if I have like a bug in my code, don't tell me what the bug is, just so that it's kind of an authentic virtual contest. Cool. So we're getting started in a couple minutes. Um, High qualified. So yeah, and just to check before we get started, is everything pretty readable? Um, like the text size is good, like the layout is okay, and my audio is okay. If anyone watching, okay, awesome, thanks. Yeah, I always just want to check because I'd hate to do a 2 hour stream and find out at the end that I messed up the audio or something. By the way, has anyone actually done this contest? I'll keep saying hi to people while I wait to start. Wow, a subscriber says hi. Thanks for the support. Yeah, so here's a link to the contest. Um, if you want to be able to read the tasks without having to read them on my screen, because I might scroll them around or use a small font size or something. Why am I doing a beginner contest? Just for fun. I think it makes better content to do a easier contest because I people don't watch me just be stuck for an hour. Hopefully. Okay. So here, I think if we just try all the extreme points, that should be good enough. Wait. Whoops. And there might be some edge case with like only be able to get a negative number. So let me see if I'll just cover that. All right. Maybe I should initialize this to min instead of max. Cool. Yeah, delete one word would just be DW. How many integer sequences? Oh, maybe DIW is the current word? I don't know. I'll have to learn that. Okay. So these are basically just digits, and we need at least 1 0 and at least 1 9. So we want to do this. Nice. So I fixed my snippets since yesterday. So I want to subtract everything that doesn't have a 0 or doesn't have a 9. How do I do that, actually? I think this is like a pi problem. So stuff that doesn't have a 0 would be 10 to the n minus... Wait, stuff that doesn't have a 0. Oh, that would just be 9 to the n. Um, and then stuff that doesn't have a 9 would also be 9 to the n. And now I think I double counted stuff that doesn't have either. So I think I can just do this. Okay, cool. This is a principal inclusion exclusion. Okay. So, but feel free to ask questions after I've gotten accepted on one of the problems. Then super happy to see them. Sorry, let me just resize my windows. Cool. So find how many integers are all greater than or equal to 3. Wait, what? Oh, and whose sum is equal to s. Oh, and the sequences can be of any length. Okay, that's cool, I guess. Oh, I should hydrate. Hmm. I guess, okay, so there's a bunch of ways to do this, I think, but I think I think one simple way to do it is to look at all the possible lengths of the sequence. Um, so so let's let k be the number, or let's let n be the number of elements, and then n is going to be, let's just say less than or equal to s for now. And then we want to count how many sequences with exactly that number of elements there are, where the terms are all greater than or equal to 3. So first we have to add 3 to each term, so this is what we have left. And if left is negative, then we'll break. And then otherwise, we're going to add, so we're going to do stars and bars here. Cool. Yeah, so what we did here is we did casework on how many elements we have, and then this is like, how do you count partitions? All right, that one's taking a while to judge. Okay, nice. Oh, cool. So you can count memory using the time command as well. That's awesome to know. Thanks. Um, yeah, I think I forgot to answer the memory question yesterday, but yeah, usually the memory doesn't matter, and then the other thing you can do is you can estimate it by just looking at like an int or a single number or whatever is kind of a negligible. So you can just look at the big data structures you use. Like if you have an array of 1,000,000 integers, that's 1,000,000 times however many bytes are in an integer. Okay. You have a bunch of points and you find the maximum possible Manhattan distance. And we can't go through all the pairs of points because n squared is too big. So for this one, let's draw a picture. Let's just say you have some points like this. So I'm thinking we probably want to do some kind of line sweep. I guess let's try drawing the example from the actual diagram. So you have 1, 1, you have 2, 4, and then you have 3, 2. And they're saying that this is 1, and this is 3. So that's the maximum answer. Um, okay. So I think here we want to do a transformation of coordinates. So if you imagine having like diagonal coordinates like this, now the Manhattan distance is just your distance along this coordinate or this coordinate, I think, whichever one is greater. Is that right? Hmm. So I think after you do this rotation, yeah, it's like if you look at all the points that are like a fixed Manhattan distance from like this point, let's say, you get like what looks like this diamond. So what you would do is you kind of expand out this diamond until you reach another point, and you would want to find the furthest away point. So I think after you do that, you can just sort, and you can take the first and the last one. Cool. So let's try implementing that. Oh, interesting. So okay. I'm using a tablet, so that's why that weird little pop-up came up. Let's just make sure this input actually works. Okay, cool. So what we want to do now is vector p. And then I guess we want to multiply by 1, 1 to rotate everything 45 degrees. Is this what we want? So let's look at this example to just make sure we got the right idea. So 0, so 2 to 6 would be 4. And then, I mean, wait, is the answer just 4 then? Wait, that doesn't sound right to me. So this point becomes 1. Wait a second. So this point becomes 0, 2. That's fine. Then this point becomes -2, 6. And then this point becomes 1, 5. And then this vertical distance would be 4. Or sorry, I guess this vertical distance would be 4. So what's the difference between 1, 5 and 0, 2? That would be 3. And the original Manhattan distance was also 3. Okay, so I think this is just right. Okay, so let's submit this. Hopefully this is right even in like weird cases. Maybe we should try one more example. So let's say you have 2 points and they're at 0, 0 and 1, 0. Okay, cool. I mean, I guess it's probably right. Great. So now we're on F, if this passes. It's taking a surprisingly long time. Okay, so here we have two ascending. Okay, great. So here we have two ascending sequences, and we want to reorder the terms of one sequence so that they're not the same at any point. So in this example, they have, and it's not always possible. Like if, okay, so here's one. I guess you have more than half the elements are the same, then you'll always have an overlap by like almost by like pigeonhole. I think it's not quite pigeonhole, but it's a similar idea. Um, okay. And then here, if there are multiple reorderings. Okay. Yeah, so here you have this thing that's like exactly half, and then you put it on the other half. Okay, so if you have the most common element is exactly half the time, then I think you can just have like the most common element in this, like in all the places where it wasn't to begin with. Like in this example. Oh, wait, never mind. Sorry, the sequences are different. Right, okay. Sorry, I was thinking you just have one sequence. In all these examples, they're the same. Or I guess this one they're not. Okay. So here, so I guess we want to find, I wonder if you can approach this almost like greedily by just, if you have something that is the same, just swap it with something else. Um, I guess also the fact that this is ascending, kind of, my first idea is just to reverse one of the sequences. Um, so for all these examples, if you just reverse the sequence, then it works. But there's definitely like cases where that's not correct. So let's add some to our test data real quick. Um, it's also interesting that both sequences are initially ascending. Well, I guess A being ascending probably makes this more convenient. B being ascending is like not relevant at all. But it saves you the effort of sorting it and it makes the problem statement a little simpler, which I guess is nice. Right. So, yeah, so in this example, reversing it doesn't work. Though in this example, doing a cyclic shift would work. Um, Actually, maybe that's the right way to approach this. Yeah, so if the first element matches, shift B until it doesn't match. Yeah, I think that's probably on the right track. So let's see what implementing that looks like. Okay. So let's see. So this is super wrong. Wait a second. Why is this like this? Oh, I see. I didn't actually offset B by this. Um, Keklux says, please stop the stream. I haven't done it yet. That's very interesting. So I guess we'll do one more thing. We'll add these assertions. Um, cool. I see some questions. I'll answer them, I guess, right after this. Hmm. Whoa. Okay, yeah, so the answer in all these cases is yes. I guess that makes sense. If you generate random cases. Okay, so here actually we tried to print yes and we got wait a second. What? So here there's an assertion failure. But here it just worked? Doesn't seem right. Hmm. Wait, why was there an assertion failure only one of the times that I ran? I'm so confused. Um, I mean, all right. Let's actually see if this is correct. So 3, 2, 6. Okay, so 9, 9. So there is a 5 at the end that matches. Oh, wait, what? Oh, because I sort A. Okay. So I don't actually know why that had an assertion error in one of the cases, but it never had it again. Whoa. That's kind of interesting. Um, yeah, asserts are basically like a nice, convenient syntax for the if false thing that people are describing. Or not if false, but if something, then return like an error or throw or like exit one or something. Yeah, what the heck? I mean, it's kind of weird. Okay, so now this is actually having like an issue. So let's take this test case and let's put it back into our. Okay, so our problem here is we end up rotating. Wait, so we end up. Yeah, so we end up rotating the answer in such a way that it causes a problem for something that we had before. Hmm. I'm like a little tempted to just switch the direction of rotation. But maybe that's also just wrong. Oops. Hmm. Wow, this person did this problem in 1 minute. That's actually really impressive. Or really in 10 seconds after the previous problem. Well, I had request problem. Yeah, so it depends. So like if I have an agenda, then I wouldn't want to interrupt it. But if I'm just doing kind of a chill, like whatever stream, then yeah, definitely feel free to request problems. Um, 80 points I think is really low, but maybe. You only have 80? You gotta watch more, dude. I might also have request problem as a sub benefit. Well, I mean, I would probably prioritize subs, but you know. All right. So how do we actually solve this problem now that our random guess appears to not work? All right. Well, I have some like vague idea that maybe this is right. So let's see. Hmm. Wait, this is actually super confusing. Oh yeah, that should be equals. So for this example, there's no issue. For this example, there's no issue. For this example, there's no issue. I'm a little tempted to just submit this. I don't know. Maybe it's right. Um, and then see what happens. Yeah, I'm basically just stress testing. Okay. Yeah, so this got wrong answer on like a small number of test cases. That's interesting. Someone says, what's happening here? I'm just doing a virtual contest. All right, I gotta think more about this problem, I guess. Maybe the reversal idea is still good. Hmm. No, that's not what we want. So the reversal idea is like okay as long as you don't have some of the same elements in the middle. But I mean, that's pretty important. Hmm. Okay, let's see. Let's try one of these examples again. So we have one, 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 two, two, three. I guess maybe we can try one example that someone asked if I've already graduated. The answer is yes, I've already graduated. Just a little while ago. So I'm kind of thinking these ones have to go somewhere that's not where they started. Um, okay, so I guess maybe we can divide this into blocks. So let's say you have some array like this, right? Then you have all these ones that you want to put somewhere else. So you can swap the ones with anything that's not a one. And then you want to be able to reorder this stuff, but you can also effectively delete three elements because you have these ones. So maybe you can kind of solve this like almost recursively. Yeah, seems pretty reasonable. Hmm. So we would kind of like put the ones into like these spots, and then we would have 2, 2, 3, 3 here. And then we have this 4 that we still need to do something with. So we could continue to move ones over. This is kind of like the shifting idea again, though. Oh, was Eric Demain teaching? Yeah, Eric Demain was a professor there at the time. I'm assuming he still is, though I'm not totally sure. So let's see. By the way, I'll update the link. Oh, are you at MIT as well? Are you guys both at MIT? Hmm. Okay, let's try the example 1, 2, 3, 4, 5. Then for this example, we can we want to solve this part. And then at some point we get stuck, right? Okay, so first, if any element is the majority, you definitely get stuck. So let's build in a case for that. Wait, that's not even right, because I'm still thinking of reordering what you have to begin with. But you have A and B separate. I keep forgetting that. Ugh, all these examples are confusing me. Okay. So, hmm. Whoops. Okay. So what's one of the examples that... So this example broke the shifting idea, but it was fine if we shifted it the other way. Nice. Someone says bro, so I'll say hi, I guess. All right, what to do? So the problem with this is you move forward, and then at the end here, you reach that these sevens are the same. And then you want to fix that. And if you fix it by shifting, you break the previous seven. So if you shift forward, that should be fine. But there was some case where shifting forward didn't work either. I guess let's try, yeah, I'm not gonna go to Task Manager now, but if you'd like to explain it in detail, I'll definitely check it out later. So if we want to shift B to the right, wait, this would be shifting, oh, this would be shifting B to the left. So yeah, we'll do this. Cool. So let's try this. Right. Hmm. This actually doesn't work. Oh, so this doesn't work on sample 2. So, okay, cool. So for sample 2, what we do is we have 1 is equal. Well, the answer is no for this one. It's actually a little unusual. Okay, so I don't. So I want to find a better way to detect when the answer is no. So what we end up doing, well, let's look at one of the examples that actually worked. So for this example, we shifted everything to the right by 1. Okay, so that was cool. Um, nice. Utkar says hello. Thanks for joining. Um, so shifting everything to the right, the problem would be if you shift 113 to the right, you shift it twice, and then it causes an issue with the wraparound. All right, yeah, let's try to limit our language in the chat. Um, Otherwise, yeah, you're gonna be like permanently banned. How is that not automatically filtered by Twitch? All right, limit our let's try to limit our usage of, I don't know, any references to race or otherwise, please. Utkarsh asks, can you tell me what is happening? So I'm currently doing this virtual contest. So there was this contest that happened like a while ago, and right now I'm trying to solve all the problems from it. Um, and I solved A, B, C, D, and E, but now I'm struggling with F a little bit. I wonder if this is just right. All right, I'm gonna wait. Did I already submit this actually? Let me see. I might have already thought maybe this is just right and submitted it. Let me check. Yeah, okay, I literally just submitted this. So like clearly it's wrong. Oh, nice. Utkarsh, thanks for the follow. All right. So what we can do with this problem? Let's look at the problem some more. Hmm. Hmm. Yeah, I think the fact that they're different arrays is definitely making this a little tricky. Please don't give away the solution though if you figured it out. Because I am still technically doing a virtual contest, so I don't want to spoil it. I should do a stream on ad hoc slash constructive problems. Yeah, I mean, that's a lot of miscellaneous problems. This is an ad hoc slash constructive problem, so I'm glad you're tuned in. All right, so maybe we can do some kind of greedy. Maybe we can do something where we build up the answer by taking elements one at a time. We might have to do something to show that we never get stuck. Hmm. Maybe what we can do is at every step, we can take the maximum element of B. So that's the one that's most likely to cause us a problem later and match it. So I'm thinking we can go left to right. Let me draw out an example. So let's say A is 1, 1, 1, 2, 2, 3. and then B is actually the same in this example. So we kind of want to match stuff. So what we do is we have the 1 and we want to match it to something. So we take the 3, then we take the 2. So in this case, we're just reversing the array. But let's say you have 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 again. So here you're taking 5, then you'd take 4, then you can't take 3, so you would take 2. Then you would take 3, and then you would take 1. So I'm basically thinking what you want to do is you want to pick the maximum possible element that you could match at each step. And my intuition behind that is that the problem with greedily picking things to match is that you might box yourself in at the very end. Like if you had 1, 1, 2, 2, 3, and you picked 2, then 2, then 1, then 1, then at the end you're left with only 3, which is bad. And yeah, so the intuition here is like if you pick the maximum element, then that's the element that was most likely to cause you a problem later on. Um, yeah. So let's try this. Wow, so my Spanish is not too good. Habla en español. I don't know what this part means. Let me translate it. Thanks for the follow. Please translate whatever you said to English so that I can read it. Okay, so do you speak Hindi? No. I basically only speak English. Oh, thanks. Um, okay, cool. So I want to find some data structure that lets me pick the latest element that's not equal to a given element. So like basically we're sorting B in reverse. Except not quite. So I guess what we want to do is something like this. Int cur equals, I guess let's see, the last element of B. So So this is our current value of A. Actually, I don't need the indexes at all. So if cur is not equal to X, then we want to add cur, and then we want to say else I guess we want to delete things from our map. I guess here we could use an iterator. Whoa. Okay, and then otherwise, what we want to do is we want to take the second largest value, if one exists. So, um, so frequency should be empty after this, right? Cool, so this basically appears to work. And then it prints no when the answer is impossible. All right, let's try submitting this. This is kind of a, I don't know, not very principled approach to this problem because I'm just kind of trying stuff and then like hoping it'll work and then submitting it. But let's just okay, so this is not good. Um, all right, let's try to find an example where this fails. Um, thanks for the kind words. Oh, I want to find something where the answer is no. Like, why? This is a wrong answer on 3 test cases. Interesting. So it seems like it's, I don't know, close, but I don't know if that's like good enough. Um, So clearly what's happening is at some point this must reach a contradiction when you otherwise didn't need to. Now I think we can change this back to the assert actually pretty safely. Hmm. Okay, cool. So like here's an example where it prints no because my idea of using the largest element leads to like a very clear contradiction. Um, Let me just put that test case in here. Whoops. So the problem with this test case is that I picked the largest thing with the intuition that it like won't be useful later. But the problem with that is that like, it would be super useful later if the largest thing doesn't show up in A at all, right? I'm kind of still thinking in the mode of where A and B are permutations of each other. Hmm. Hmm. Maybe I can just go through and if there's a spot where they don't match, just fix it somehow. Hmm. How much time is left in this virtual anyway? Like half an hour? Why doesn't it tell me? It tells me if I click on all this. Hmm. I guess what I'd want to do is instead of doing this greater heuristic, which is like, oh, hopefully it won't show up later, I can actually look at what shows up later, like concretely. Um, so basically what I want to do is I want to look at all the common elements that are still upcoming, and I want to pick things now that would have been common elements later. Yeah. Because if I do that, then I'm kind of improving the state of what's going on. So like in this example, if you have one, one, two, three, or actually let's use the counter example that I just wrote out. So if you have like one, two, three, and three, four, five, the common element here would be 3. So we want to try to prioritize using the 3 as soon as possible because that prevents us from a potential contradiction kind of down the line. So let's look at another example. Well, I guess in this case, right, if you had something like this, then everything is a common element. So it doesn't really tell me which one I want to use. And that's kind of like not great. Um, I guess let's see. So if I'm building this up and I first put in a 2, then now that I've put in this 2, 2 is no longer a common element. Well, I mean, but it's also not available, so that doesn't even matter. Maybe I want to put in the common elements that appear latest, but only if they're common elements, and then I want to secondarily pick non-common elements. It's kind of, I don't know, a little clunky. So let's see 1, 2, 3, 4, 5. So if you have, so first you'd want to put in 5, then you'd want to put in 4 because it appears latest. I'll go to the next slide. So if I had something like 1, 2, 3, 6, and then 3, 4, 5, 6, then I do want to pick up this 6 kind of earlier so that I don't have a problem with it later. Yeah, I'm leaning forward a bit to use my tablet. Maybe I should just move it closer to me. I kind of feel like I'm missing something. Like, I don't think this problem is supposed to be like that hard. Let's see. So, well, if you have non-common elements, you can just use them wherever. So I guess that's kind of fine. So I feel like taking the latest common elements should be good heuristic. It's just this is getting a little bit messy. Or like it's been a little bit messy. Like I'm kind of just doing random stuff and then submitting it, which I don't feel like is the best approach. Okay, so let's try to approach this maybe a bit more systematically. So, yes, it's impossible if you have so if you have a single element that appears more than n over 2 times in both arrays, you oh, okay. Yeah, so if you have a single element that appears more than n over 2 times in both arrays, you end up, if you imagine assigning that element a bunch of indices, you would end up assigning it that index twice. And I think this actually might be a good framework to think about the problem. So you have 1, 1, 2, and then 1, 1, 3 in one of the examples. So you basically have all these numbers, and you want to assign every index exactly twice. So you have kind of your first 1, 1, 2, and then I guess you always assign those the indices 1, 2, 3, right? And then you have 1, 1, 3, and you want to assign these some indices. So if you kind of look at what indices you can assign them, you have to end up assigning 1 and 2, or you have to end up assigning at least 1 or 2 to one of these once. Like these 4 indices, normally all those indices would need to be distinct. So I guess maybe that's another way to think about it that might be like slightly fruitful. So if we imagine like 1, 1, 2, 3, and 1, 2, 3, 4, then we want to assign the indices we want to assign indices to each of these numbers. Um, so that we don't assign anything the same index twice. And we have 2 copies of each index. Well, these indices are kind of forced, so we can just do that. And then we want to scatter the remaining indices 1 through 4. So we have to assign 1 more to 1. Well, we have to assign 1 to each. So we have these kind of 4 blanks. And we know that we can't assign 1 or 2. Yeah, so if you have a single element that appears more than n over 2 times, this does make it pretty clear that it's impossible. So my guess here is that this is an if and only if. So if you don't have a single element that appears so many times, then you can always do it. But the question is, what's a clean way to find that permutation that actually does work? So So how would we assign these? So we could try doing the smallest index that doesn't cause a contradiction. And then in this example, that actually works. So let's try that on 1, 2, 3, and 3, 4, 5. So we have 1, 2, 3, and then so these are our values, and these are the indices we've already given them, and then these are what we need to fill out. So we can give this one 1, we can give this one 2, we can give this one. Okay, I mean, sure. So that's just the existing order, just worked. Um, okay, I think this might just be a repeat of our previous idea of offsetting. So this might not be like an interesting or novel idea. So let's try this on the example 1, 1, 2, 2, 3, and let's just say that's repeated 2 times. So we have 1, 2, 3, and then here we have 1, 2, 3, 4, 5, and then we have to put in 2 here, and 1 here. So here we can put 3 and 4, here we can put 1 and 2, and here we put 5, which is a problem. So we don't want to do it that way. I wonder if you have a problem, you can always fix it in a single swap without causing another problem. Let's try an example. So if we have 1, 1, 2, 2, 3, and then we have 1, 1, 2, 2, 3. I'll go to the next slide. So if we have this, then what we'd want to do is we want to fix, so here's a problem, right? So let's try fixing it in a single swap, so then we get 2 and 1. Now here's a problem, so we get 2 and 1. And now here's a problem. These apparently aren't problems anymore. So now we have a problem here, and we want to fix it in a single swap without causing another problem. So we can actually just switch it with whatever, I guess. Is that always the case? I mean, let's try adding some more 3s here to be sure. So then we could try swapping it with the previous element. So we get this, and now we have a problem here, and we can swap that with, so we can't swap that with the previous element, but we can swap it with, I mean, something. The problem is how to find that something like cleanly in all cases. Hmm. Let's look at our examples again to see if we had any tricky ones in here. Can I make this stop showing up? I don't even know what it is. Oh, interesting. Okay. So I guess I can use handwriting to type. Ah, yeah, I can use my pen to write in the box. Cool. So can we always efficiently find a valid swap candidate? Yeah, I definitely don't want to use the handwriting. I'd rather just type. The handwriting is just nice for like this kind of whiteboarding stuff and like, for writing math. I was previously using an iPad and now I have this Wacom tablet. So, hmm, can we just find any random swap candidate? So we just want to swap. So let's say so let's say we have like an X and like an X like this, and we want to make a swap. So we want to swap this into another position so that this value is not equal to X and this value is not equal to X. Hmm. And that includes after any previous swaps that we've done, which is like a little bit of the tricky part. Like in this case, right, we could swap it to here, except this 3 already swapped in there. So, nice. We have to try to clutch this out. Whoops. Okay. So, maybe we can make a list of all the valid indices, or make a list of the invalid indices, perhaps. Ah, yes. Okay. So the other thing is if we know that at most half the elements are equal to a given element, we can always make this swap without introducing another problem. Okay, so this solution definitely works. The only problem is potentially implementation. So for implementation, we want to find any index that doesn't have your element in either spot. Oh, maybe we can consider each block so that things are pretty simple. Yeah, I think that should actually work. Hmm. So I'm thinking we kind of have like blocks and we want to swap stuff within the blocks. Hmm. But then after you do the swapping within the blocks, your stuff gets desorted. which isn't great. All right, so let's look at another example. So if we have 1, 1, 2, 3, 4, 4 or something, and then the other thing is like 1, 2, 2, 3, 4, 5. Then, all right, so we want to swap this 1 somewhere, and we can't, we can just swap it anywhere that's after both these ones, and that would be completely fine. Um, so we would swap it with this 2. So then we would get 2, 1, sorry, 2, 2, 1, 3, 4, 5. And then we don't want to swap this 2, then we don't want to swap this 1, then we do want to swap this 3. So we can swap it with anything after it. Oh, right, okay. So you can always swap something with what's after it. So then this would be like 4, 3. And then after you've done that, hold on. 2, 1, 1. Okay, so this isn't sorted anymore. It's a 2. Okay. So, yeah, but you want to find the first element that's greater than your current element. So I think you can keep doing that. Yeah, so if you have a collision, you know that there's going to be at least one element after it that's greater than it, unless your element is the very last element. Like, if we had this like 6. Okay, so we do this swap, and then we have this 4, 5, and now we have this 6 that we want to swap out. So this is our array, and now for this 6, we just want to look, I guess there could be 6s like anywhere. Maybe we can always just swap the 6 with whatever is at the beginning. I think that should work. All right, let's try implementing this. Um, nice. I have 2 wrong codes. Okay. So what we want to do is first, we want to count the number of elements that are in both arrays. So I guess oh, that's not even right. I just need the total number to be more than n. And now I think the answer is always going to be yes. Okay, so if AI is not equal to BI, I guess I should see how much time I have just so I can, like, give up appropriately. Okay, cool. Let's see if we can do this. So otherwise, so now I want a binary search for the first thing that's after where we are. Okay. So this works for some of these cases. Now we want to test this. So that's wrong. Um, okay, so then I believe we can do. Oh man, I hope this is right. Oh, nice. Okay, this is wrong. So, All right, I'll just try submitting this and then we'll give up. I'm pretty excited to read the editorial since this is a seemingly a pretty tricky problem. Okay, nice. So we got accepted with 30 seconds left with this kind of cobbled together solution. So that's pretty, yeah, that's like definitely a PogChamp moment. So cool. I guess I'll go over the problems starting with, oh, that's a cool emote. Oh, nice. It's from Nick Wu. Is that a cone? Okay, cool. So I guess let's go over the problems. Well, let's see how we did. I guess we got like last place out of all the people who solved all the problems. Um, all right, so let's review the problems. Starting from A, should be pretty quick to go through some of the early ones. So, okay. So for A, it just says you're given an integer that's between 0 and 1 inclusive, so it's either 0 or 1, and you have to print the other one. So there's a ton of ways to do this. You can do it with an if statement, you can do 1 minus it, you can do 1 XOR it. I mean, it's a pretty simple implementation problem. Crow says, what the heck? Regarding, regarding what? Yeah, I'm actually confused. I thought that there wouldn't be ads if in the middle of the stream. Yeah, what's up with this problem? I mean, it's a beginner contest number A, or not number A, but problem A. Typically, those are intended so that like anybody who can write code can solve them, just so that I don't know, I guess for beginners, as opposed to code forces where I feel like sometimes A could take beginners like, 45 minutes or something because it's pretty there's still some tricky idea. All right, so for B, um the way that I did B, right, is you want to use so there's like a few different cases here, right? Like A and B could both be negative, they could both be positive, and like same with C and D. But basically, you always want to use one of the extreme points, because you want to make the biggest number you can, with the exception of, so you either want to take A and C, I guess, to make the biggest product of two negative numbers, or you want to take B and D to take the biggest product of two positive numbers. Um, with the exception of if the answer is always negative, which would be if this is something that's always negative and this is always positive, or vice versa. So in that case, you would want to. I guess that's not even really possible. Yeah, so I think some of these cases are unnecessary, but this definitely covers all the cases. The only thing you want to avoid, so this is a small constant number of cases, so it's completely fine. The only thing you want to avoid is checking all the cases, which would, time out. All right. So for C, this is I actually like this one. So basically what we want to do here is we want to use the principle of inclusion and exclusion. So here we're counting all the possibilities for sequences, so that's 10 to the n because each digit could be anything. Then we want to subtract 9 to the n, which would be all the sequences that don't contain a 0 at all. So you only have choices from 1 through 9, hence 9 to the n. And then this is subtracting all the things that don't contain a 9 at all. So everything would be 0 through 8. But when we subtracted these, we double counted when you would have a sequence that has neither 0 nor 9. So we want to add those back in to compensate. And that's the principle of inclusion and exclusion. Cool. All right, so D I thought was a pretty cute one. I'm kind of curious what the editorial says. So I'll open that. Okay, so they have a dynamic programming solution, which is like, all right, so yeah, you could do this with dynamic programming, I guess. Find the number of sequences whose terms get to, yeah, F, I tried like 5 different greedy solutions, and then I got one of them to work with like 30 seconds left. Um, I guess this doesn't show the timestamp in the contest. Anyways, how can you tell if greedy is gonna work 100%? Uh, okay, so normally what you would want to do is you would want to prove it. You wouldn't want to just guess and submit. But sometimes you want to guess and submit, like especially if you're low on time. And having a chance of being correct is better than no chance. But I think in general, this was kind of a do as I say, not as I do moment, where I just kind of guessed over and over and submitted over and over. But I think that taking a much more principled look at how to solve the problem would be better. And we kind of saw that once I thought about it a little bit more clearly in terms of this and tried to show that it's always possible if that's not the case, then we had like a better time. But anyway, getting back to D, so the way that we want to solve D, so they had a solution using dynamic programming, which is like, all right, you can do that. But I think there's actually a kind of like more intuitive solution for D, where, okay, so first let's solve the simple problem of number of ways for n numbers to sum to s. Greedy solutions are more about intuition. Crow says always use DP. So a lot of the time DP would be too slow if you have a problem where you're supposed to use a greedy solution. And then Saksham Garg says greedy solutions are more about intuition. I think there's some intuition with coming up with a greedy solution, but then I think proving it usually shouldn't be too difficult, actually. Though it is typically more tricky to prove than like something like DP, where usually when you're proving a DP solution, it's just because it boils down to an exhaustive search, but more efficient. Anyway, so for D, we want to count how many ways for n numbers to sum to s. So, for example, if you want 3 numbers that sum to 6, one way to do that would be like 1, 1, 4. Another way would be 0, 3, 3. Another way would be 4, 2, 0, etc. So there's a cool way that we can think about it, which is imagine you have 6 balls. And this is like the standard combinatorial technique of stars and bars. And then you have 2 dividers. So in this case, this would be 1, 1, 4. So you want to figure out the number of ways to order these 6, these s different balls and these n minus 1 different dividers. So that would be s plus n minus 1, choose n minus 1. Harsh888 says, just joined, what are you doing? So I guess I'll update my info. So now, so now we're just discussing the solutions to this virtual contest. And I guess I can. Will you be doing anything after this? I might end the stream after this, though. If anybody has any particular questions or any problems they want me to look at, I might take a quick look. Yeah, I'm not totally sure, but I don't want to do like a super long continuation of this stream. I should go have lunch at some point. So anyways, so here, this is like the standard technique of stars and bars, so we get this, right? So now we want to extend this to the number of ways with each number greater than or equal to 3. So up here we had everything greater than or equal to 0. So the cool thing is if everything's going to be greater than or equal to 3, we just know that we can subtract 3n because you're going to have that much for everything, and that's kind of your new value of s. And then you just solve the same problem. Okay, so now that we've done this, we just consider all values of n from, I guess not 0, because that would be like nothing. So we just consider all values of n, and then we can consider them up to like s over 3 or something. So if we look at the code, that's what we ended up doing. We consider n equals 1 to s, and then we have the number of leftover things, which is s prime, s minus 3n. And then if this is negative, we can break early. This is kind of a way to get this to s over 3, but without any potential off by 1 errors. Because the thing you really care about is this being negative. And then here we just do the binomial coefficient. So that's how we do D. So pretty cool problem. Now let's read E again. So I kind of started to draw a picture here. Cool. So for E, what we have is, imagine you have some dots and you want to find the Manhattan distance between them. So if you want to draw all the points of a fixed Manhattan distance from a given dot, if you kind of just draw this out, this looks like all the points within this diamond shape. So if you do that, oh, by the way, Crow, yeah, feel free to link your problem in the chat, and I'll click on it and see if it's doable in time. And then, I'll get to it after these explanations, but feel free to link it now. Beginner question. In C++, what does colon mean? I think it means a couple different things, but I think one of the things that it means is a for each loop. So, okay, so this gives us the idea of rotating all the points and doing a coordinate transformation. So our transformation would be x prime equals x plus y, and then y prime equals x minus y, or something like that. Yeah, I think that's what we do. So we want to rotate the plane 45 degrees, and once we do that, it's a simple matter of finding our minimum and maximum of our transformed x and y coordinates. So let's look at the code for that. Yeah, so what we're doing here, and this is kind of nice, I just, if you can, it's nice to pre-write some basic operations. So I have this pre-written point class that I use, courtesy of Socket, and so what we're doing is we take our original points and we rotate them all by 45 degrees by multiplying by this other point. And if you do this rotation, you might actually... So technically, if you were rotating here, you would be dividing by square root of 2. But we don't actually want to do that because we want everything to stay as integers. So we do this rotation. This is multiplication because you can imagine if your points are complex numbers, you're multiplying by 1 plus I to rotate like that. And then once you do that, you just find whether the answer is in the x prime direction or the y prime direction. And this is another example of colon. So we're doing a for each loop across each point, and then we're destructuring it into the x and y coordinates. Yeah, I have a pre-written pair class in Java, and it's pretty annoying. Because I have a separate pair class in Java for like ints, and then for longs, and then for other types, because I don't want to use objects, so I have to use primitives. Yeah. Okay, so that's E. All right, let's do F. And by do F, I mean let's read the editorial. Well, I guess I can try to briefly outline my idea for F. So my idea was that if you have an element that appears, so this is actually wrong. What this should say is if your element appears greater than n total times. And I realized that later while coding. So then my idea is that if I don't have that, I can always do a legal swap. And then I try to go through and do those swaps. So I always swap something with the next element that's greater than it. And then when I reach the last element with nothing greater than it, I just start swapping it with stuff from the beginning as appropriate. And it turns out that always works. And that's what I have here in my code. First, I check to see if anything appears too many times, and I print no. Then, if you don't need to swap something, you just move on. And then if you do need to swap, I find the first element that's greater than it. And if none exists, that means that we're at the largest element, and then I just swap with stuff from the beginning. Though I'm not completely sure why this works. So let's see if this has a more elegant explanation. If the value appears more... Okay, so this is what we already did. This is a little confusing. I'm kind of curious to read what the discussion on Codeforces said. Someone asked how to do F and the contest was still going. All right, so let's read this, I guess. Um, Whoa. Oh, wow. This is actually a very simple code. Okay. Okay, interesting. So it looks like the answer here... Wait a second. So it looks like they always perform a... Wait, what? So they always perform a shift of the input? I see. So you shift B by X elements to the right. Interesting. So that's what we tried near the beginning, but clearly we did something wrong. Okay. So you want to shift B in such a way that if you have an interval, then okay, yeah, so you shift it onto the next interval. Hmm. So I'm kind of curious what was wrong with my original wrong solution of F then, because I thought that's um because I thought that was what I did. Someone asked, where do I work? I'm a software engineer at Google. So, hmm. So here I do shift things to the right. And such n always exists. Yeah, I would have thought this would be correct. Um, I mean, this almost looks like it's the same as what I did, right? Oh, I see. Okay, so the problem with my solution, I think, is that I don't shift by enough. Like I could wait, is that even right? Like if I shift my stuff to the right, then what is this a greedy solution? I guess this is kind of similar to what we did, but it doesn't explain it. Oh, these are probably pretty big cases. Okay. Because their runtime was so high. All right. Well, let's move on. I'll click this problem that Crow suggested. Given a lowercase string, return the number of palindromic substrings. Oh, that's kind of cool. They're little inline definitions. So I think there's a standard algorithm that solves this called Maneker's algorithm. I've never actually used it, but I believe it's. Oh, I guess it finds the longest. So this problem actually just finds all the palindromes in O of n. But yeah, let's see if we can do it. Um, yeah, wait a second. So this problem, I think you don't even need to do a DP. I think, can't you just check all the palindromes in n squared? So like, okay, so the simplest way to do this problem, I'll just open a new slide, is like imagine you have some string like taco cat, like they described. So you can just try each element as the center of your palindrome and try to expand it outward as much as possible. Um, so there are n different starting points, and then it could take up to n operations to extend out to the end. So you end up with an n squared algorithm. And so I think this is like, whoops. I think you can just do it like that. So I guess, hi, I'm new to competitive programming. Where can I find those? So the contest that I just did is Atcoder beginner contest 178, I think. Um, and then what do you mean by paid contests? Like people, like you pay to compete, or people pay you to compete, or something else? So this might be oh, do I have to sign in? I hope we don't have um another mishap where I leak one of my passwords on stream like I did before. What programming language is best to learn for nuclear engineering? I'm not sure, but try the Atom text editor. I think that one should be relevant. Also, sorry, if that wasn't clear, that was just a like a silly pun. I don't actually know anything about nuclear engineering. Okay, paste. All right, so now let me copy something else so that I don't accidentally paste this. Do I have a Discord? The answer is no. Should I create one? Nice. Okay, so this is wrong. Let's see why. Oh yeah. I didn't think of odd length and even length. All right, that's a good catch, but um okay, so people are asking okay, so yeah, so Crow says I didn't know you had an account on this. Yeah, so I think I was one of the I saw this really early on when I think Lawrence, the person who created it, like posted it online somewhere. And I like checked it out for a bit and then I haven't really used it recently. But it's a pretty cool site. I think it used to be very focused on like the kind of collaborative solving and now they have a bunch of contests too. Hmm. But yeah, so I think the odd length and even length thing would be the trick for this. I also believe that we can probably fix this. Oh, this has Vim shortcuts? I didn't know that. Okay, cool. So this is like an n squared solution, but basically the idea, right, is you consider all the center points and then you expand outward. And the basic idea with that is that um, if you want to check a string of length 5 to see if it's a palindrome, there's a string of length 3 inside it that you should have already checked, so you don't need to reuse extra work. So the naive solution to this would be to look at all substrings, which is n squared, and then check each substring in O of n. So that would be an n cubed total solution. But yeah, so the idea here is like if you have some string like ACOCA, like they had, and then you want to check Taco Cat and you know that the middle is already a palindrome, you only need to extend it by one letter in each direction. What's with the 2D DP thing? What's the 2D DP thing? Like, did somebody else say to do a 2D DP? Like, here we're just kind of trying everything, and it's, I don't know, it works pretty well, and I think this is very clear and easy to understand. Um, oh, so Ordinary Boy asked contest with prize. I think there are some contests with prizes, like Google Code Jam. Um, but I think to get a prize, or like Facebook Hacker Cup, I think had prizes this year. I saw some people made like a few $1,000s. But I think to get the prizes, you have to be incredibly good. So I think it's not really a realistic path for most people. Um, okay, I see. So it seems like what Saksham Garg suggested is basically very similar. Yeah, okay, so it seems basically identical to what we did here. Um, where what you do is the only difference is here I'm just adding to the answer directly, but and I'm iterating in an order where I don't need to store the array. But yeah, basically like the core concept between suction guard solution and my solution is the same, which is that you can take an existing palindrome and expand it by one letter in each direction, and that saves you a factor of n in your runtime. Cool. Then Crow said I'm hooked on this site. Cool. What's your username? And then it's Crow with two W's. Oh, okay, so I have some like vague memory that like were you on this site like super early, like a year ago or something? Or maybe like this spring when it came out? Because I feel like I actually remembered being on this site a lot when it first started out and then seeing your name a lot. Okay, maybe not. I remember before the pandemic I was on this site and I thought I saw someone named Crow, but maybe I'm just imagining it. Anyways, okay, and then Keklux asked, do hard binary search problems appear in interviews? It definitely depends. I mean, depending on where you're interviewing and what your interview style is, or what your interviewer's preferences are. Um, but yeah, I mean, typically interview problems have a good amount in common with competitive programming problems. Like they're kind of these like at least for like entry level roles, I think typically interview problems are problems like this where you have like a well-defined algorithmic task and you want to solve it. Um, cool. All right, so I think now is probably a good time for me to end the stream and I'll go have lunch. Um, but yeah, cool. Glad we could do this problem quickly. Oh, and I guess I'll plug. There's this algorithm which I'm actually not familiar with. But if I ever need it, I guess I'll look it up. But there's this algorithm which allows you to solve this exact problem in O of n by doing some more sophisticated method of combining palindromes, I guess. Do I have common algorithms memorized? Great question. So it is definitely good to be familiar with a lot of classic algorithms. Like this website has a bunch. It's good to know. Basically, the idea is like if you have some standard algorithm, you typically won't see that exact problem on a contest, but it's very good to have the general techniques, or be able to try to use those as building blocks to a solution. Because, for example, like rederiving like binary search or like rederiving like how a hash map works or something like that when it's just like a small part of like a larger solution that you're doing would be super annoying, right? It's kind of the analog of how in math you have like kind of pre-proved theorems and stuff that you use when you're proving other theorems instead of trying to prove everything from like the most basic axioms every time. But yeah, I would say like that's kind of the general idea. Um, it's really good to be familiar with these standard things, and they don't often show up on contests, but they do sometimes show up on beginner contests and on Atcoder beginner contests. And then the other website is this CSES problem set where I did some of the DP problems yesterday, and these problems are all basically like textbook problems, which, isn't that fun from a competitive programming standpoint if you've already seen them before, but it's super valuable to know all the textbook problems, because the problems that you'll see on a contest will basically be more complicated or disguised versions of those, to some extent at least. Cool. But yeah, thanks everyone for joining. Um, and yeah, I actually did. So yesterday I did all the dynamic programming problems from CSES, and I'm gonna put them up on my YouTube later. So feel free to subscribe there. Um, Happy Mood says, please do a stream on game theory. That actually sounds like a great idea. So I have a couple ideas floating around in my head for topic streams. I think my next one will probably be expected value in combinatorics, since I really enjoy that topic, and I think there's a lot of cool problems there. But another idea that I was thinking about was doing game problems, because I think that's an interesting topic. And the thing is, I don't want to do a topic stream on something like um I don't want to do a topic stream on something like segment trees or binary search or something if I can avoid it, because that kind of spoils the problem. My last topic stream was on number theory, and like that's an example where all the problems have a common theme, but knowing it's number theory isn't really a hint. Whereas like knowing it's a segment tree problem is a pretty huge hint. Um, cool. Y1INK, thanks for the follow. By any chance, is that like Young Link in Smash? Or is it a coincidence? Yeah, okay, cool. So yeah, I think one of my next streams will probably be expected value, but then maybe after that I'll do game theory, because I think that's another pretty fun topic. And it's kind of interesting to see the thought process behind some of those problems. Okay, so yeah, thanks so much everyone. Ending the stream now, and thanks again for joining.